Hello folks, my name is Andrew Delamere. I'm a Senior Specialist Architect for IoT in the EMEA region. Today we're going to talk about overall equipment effectiveness, or OEE, but we're also going to talk about how to extend OEE and how to make OEE more beneficial to your business and by using other methods and techniques to kind of round that off, to understand more about what you're trying to do. In the next 45 minutes, we're going to go through some products and services, and we're going to talk about how to leverage these things to make your business better. Now, what we're going to start with is we're going to start about where is AWS and what are we doing with industrial customers at the moment. So generally with OEE and understanding industrial workplaces, we're trying to make things better. We're trying to add a new dimension to data. Now, that's a big phrase. What are we trying to do there? So we're trying to add performance metrics to industrial processes as a really good example. Because if you can add more performance metrics to industrial processes, you've then got more metrics that you can put into things like machine learning or state machines, and you can actually work out more from what you've already got. So you can say, I know I've got 5 different lines of business that are making things. I want to put all of those through into the cloud, and I want to work out for each one of those lines, which one's the best and which one's the worst. Because with machines, they degrade over time, they need maintenance, they need a constant evaluation to be at their best performance. Management of energy resources and efficiency, looking at the azimuth of the sun, for example, when you're looking at solar panels, moving those solar panels to best align with that. Looking at your supply and your power supply and how many watts or megawatts you're producing and who's taking that and the value of where that energy is going. And then we've got things like monitoring patients in hospitals. I mean, from a sensor perspective, you've got all sorts of different sensors to track the heart rate, to track movement of the patient. You've got the availability of where nurses can see what's actually going on with your biorhythms. So, so you're well looked after, even if a nurse isn't standing right in front of you or a doctor isn't standing right in front of you. This is where we're going with hospitals. And then we've got things like transportation. So we've got things like V2X. We've got generally the car industry and autonomous transport. Then we move into crops and health, and we go, okay, well, there's lots to do there. We can look at soil sampling. We can look at robotizing tractors. We can look at spraying. We can use drones to look at a field in its largest state. And we can gather, it's all about gathering data there. And then we've got things like inventory tracking, factory safety. But then we've got smarter products and experiences. Now, moving on, we're going to talk about the factory, and we're going to talk about where AWS can help inside a factory. Now, in general, what we try and do is we try and work out, first of all, what's there. Okay, so every machine normally has some sort of outcome, unless it's incredibly old. And if it's incredibly old, we can put sensors on it that do the same thing. So we can have sensors that monitor gauges, we can have sensors that monitor bearing rumble and all these sorts of things. But if it's got something like a PLC or a SCADA network, we can connect into that. And then we can look at things, very simple things, like we can look at condition monitoring. So we can say, we can take a bearing rumble, pass it through a fast Fourier transform, for example, and go, okay, so the bearing rumble was like this for the last 3 weeks, but it's changed now and it's got worse. We're seeing more harmonics. So that's probably a bad sign, and perhaps we need to do some maintenance on it. So that's a simpler way to do that. Then we've got things like production monitoring. And with production monitoring, you have the ability to go, well, okay, so I know what the machine's doing. I know what the sensors are doing there. But I now need to work out, is the product still right? Has something changed? Is there humidity in the factory? Has it got colder? Has it got hotter? Are my molds still good? Is is the factory production line still working as it should be? And then we have workers' efficiency and safety, right? So are the workers doing what they're supposed to be doing? Are they in the right areas at the right time? If you've got heavy machinery moving around, this is quite critical because you don't need accidents. Accidents are you know, they're costly in people as well as time and other things, right? So we need to stop doing that. So we're focusing on the factory there. We're focusing on, you know, again, things like that. And what we're trying to get to is we're trying to get to quality management. We're trying to get to, you know, predictive maintenance. So once we've known what we're monitoring, once we've known how it works and what people are doing and how the production is working, we're trying to work out, so is the quality still the same? Yes, no. And we're trying to work out from a predictive maintenance perspective, when will it fail if it does? Because if you can tell if a machine's going to fail and you maintain it beforehand, you don't necessarily get a failure in the middle of a production run, which is expensive and time consuming. And then we've got things in and out of the factory. So we've got track and trace, and we've got digital twins. So we can with track and trace, we can work out what supply is doing. So is all my equipment in the factory and its component parts ready to be assembled? Have I got equipment going out, or have I got product going out in a reasonable time? So I've got warehouse space to produce more space for my next run. And then the last thing there is digital twins. Have I got can I produce a digital version of my factory which my staff can look at in real time, they can model against, and they can kind of work out what's actually going on with my sensors, and see, you know, what piece of factory is not quite right. So that's where we're going today. And then we're going to go into AWS IoT in the first instance. So we're going to look through some of those products and services, and then we're going to move into where we're going with that. So business outcomes within industrial IoT from the IoT team is we're trying to increase operational efficiency. All right, so we're trying to look at data. We're trying to make intelligent decisions. We're trying to increase the efficiency of your services and products. And then we're trying to do better relationships with your customers. So once we know the product's been made, if we can now know the batches, we can now know the component parts from supply, we can now know where the plastics came from if you've changed manufacturer, and we can start looking at products that go out into the field, especially if they're IoT connected, and we can work out why product in batch 1 is better or worse than a product in batch 2. Okay, so we can grow revenue based upon understanding, how your product works, working with you and kind of producing, helping to produce a better product with data metrics over time. So how do we do that? What does this? Because everybody goes, well, Andrew, how does the cloud get data into it? How do you manage to actually go into a factory, pull all that data out, and actually add value to it in the way that you're saying? And that's a great question. Okay, so first of all, we're going to start with this picture here, which looks pretty comprehensive. It's got our edge location here, AWS Edge. What that generally means is it's devices that sit in or around the factory and actually pull data out of either what's there or sensors that you've placed to understand more. Okay, so we can make sensors out of FreeRTOS, and FreeRTOS is one of our products that we've taken on. We've taken on FreeRTOS as an operating system. We also work with a lot of hardware vendors that use FreeRTOS, like NXP and Realtek and companies like that, Nordic Semiconductor, who also integrate FreeRTOS into their products and platform. We then have on the bottom there, we have AWS IoT Greengrass. And Greengrass itself is an edge processing gateway. It's all software, so you can put it on a Linux box, you can put it on a Raspberry Pi, you can put it on an industrial PC. And what it does is it has the ability to take pieces of the cloud and run them in the factory, in your plant. So, for example, you can run Lambdas, you can run containers, you can run machine learning, and a whole bunch of other stuff. And what we're going to talk about today is Sitewise, which is a service that runs on top of Greengrass, and it manages your field assets via your PLC network. So, and it also looks at SCADA-based historians. And what you've got there also, what we've got in this picture also, we've got things called outposts, which are a larger version of what you could argue what Greengrass is doing. Okay, and it's a set of racks that extend your cloud experience to the edge into your factory premise. And then the last bit at the top there, we've got Snowball Edge and Snowball Edge Cluster, which are rentable PC units that are controlled by AWS that allow you to pull data out of physical locations. That could be colo, that could be factory edge, and actually process them. And that whole process of pulling that data out and putting it into the cloud is managed as an AWS service. So you don't have to worry about where am I sending the Snowball Edge to, what is it doing when it's there, how will my data appear? It appears in an S3 bucket of your choosing. And then in the cloud, once you've got all that data out of your factory and you've gone, okay, I've got all that data out, what do I do with it now? Firstly, we've got data lakes. Now what data lakes do is they take data from various different sources around the factory, various different protocol-based resources. It could be data from your ERP system, it could be data from your production line or your quality control, and put those in buckets so we can actually look at them via Athena, which is a very advanced query engine, and then pop that into SageMaker so we can actually run either fixed machine learning models or custom machine learning models if your company is good at that sort of thing, and actually understand what's going on with that data. So you can actually say, well, actually my quality control, for example, went down last month or went up. My ability to do these things. And then lastly there right on the right hand side, we have reporting and of course condition monitoring. So the reporting from QuickSight allows you to take that historical data which has come out of the data lake and allows you to report against it. So you can say with a visual format that your staff can look at without needing to log into AWS. They can see all these different dashboards and they can work out what's actually going on with the plant today, from last week, from last month, depending on how you manufacture things. And events there is a state machine-based condition monitoring service that can take multiple inputs from things like IoT Core, from Sitewise, from third-party APIs, and actually understand the state and then feed back that state. So for example, if you've got a water pump in your plant that has a thermal input and a thermal output, and then a temperature on the pump itself, you can actually take all those three values and you can work out from the pump using events. You can actually watch the state of temperature on all three values and actually say, if temperature equals more than this on the input and the fan speed experience is more than that, then you either need to open the pump more or something's gone wrong with the impeller and there's wear, and you can look at also all those sorts of things. So that's pretty useful. So we have a lot of products and services that we can bring to bear. Now, let's move on to AWS IoT Sitewise and look at that specifically, because that's what we're going to be talking about today. Now, AWS IoT Sitewise collects data from the plant floor with a local gateway. And what that means is it sits on that green grass, which we're going to go into in a little bit. And it's a big connector that takes data from OPC UA, or it can take data from Ethernet IP. And what that means is your existing services and products within the factory can talk to it. It will take that data out, and then it needs to do something with it. What you can do with that data is you can you can build models, and what those models are is they are constructs of what a specific piece of plant in your factory can do. What I'm going to do in my example here is talk about a wind turbine, because it's fairly easy to understand. Now, once you've got your model, you can then build assets from it, which is using that model multiple times. So for example, if you've got a stamping machine in a car plant, you build one model, which has values of the pressure of the stamper, it has values of the impression, it has values of the heat that's created, and a couple of other values as it stamps the metal part, as well as like things like oil inbound and water inbound to cool things down. And then what you can do with that is, if you've got 10 stampers across 3 different plants in an area, you can take that model and use it as many times as you need to. And then once you've got all that data, once you've built those models and you've applied them to assets all over your factory, you can then look at that data with calculations. So each asset will then have a set of calculations that the model can bring to bear. Yeah, so you can actually calculate things like total pressure required for the stamper to work. You can then look at how much oil it's using versus how much it used last week, and things like that. And you can actually then look at parts of your production line in more granular detail. Now, what we're going to look at here is we're going to look at an asset model versus an asset. So as you can see here in this slide, in the asset model on the left-hand side there, we have a make and a model and a location. Okay, then we have a rotational speed. So we're starting to get to measurements. Rotational speed, torque of the wind speed, wind direction, and all these sorts of things. And then you can transform those. You can do some transforms, which tell you that rotational speed is RPM over 60, and then you've got torque, and then you've got K&M, right? So times by 1,000 to get your torque out of your rotational speed. Then you've got average power, which is average torque, and you can keep building metrics. The whole point of this is you can keep building metrics over time in your model, and then you just keep deploying updates to your model. And then that becomes an asset. So you apply a wind turbine, a physical wind turbine to it, and the data that's coming in from the connector, which we saw earlier, is matched against that asset and that model. And it will then show, for example, we've got here a Siemens wind turbine. It's got a location in Northings and Eastings, and then we've got a rotational speed currently, but it keeps capturing that information. We've got our torque, we've got our wind direction, we've got our rotational speed, and then we've got our power, average power consumption that's being pulled out. So you can store that data, you can send it to an S3 bucket, but you can also monitor with it as well. So you can actually sit there and watch it and actually pull alerts out of it as well. So that's the value that we're trying to get out of this. And here's a classic example of that, where you can see that what's actually happening is our asset here is the OPC-UA configuration for our asset. It's got its OPC-UA endpoint, so there's an OPC-UA server sitting there, which is giving us the information, which is looking after the wind turbines on the site. We're pulling that OPC-UA information out with a subscription. We're then collecting that information. We're then analyzing that based upon the asset model, and then we're publishing that as values into the Sitewise, so you can actually see that either as an output in S3 or in our portal-based application. So what are we trying to get out of that? So what we're actually trying to understand here is we're trying to understand what's going to go wrong with the wind turbine over time. We're trying to actually get a set of metrics out of the device in the field, and then work out when is it not good? When is it not going to be a good bit of kit? When does it need maintenance? When does it need to be stopped because the wind's too high? In this wind turbine example. So what we're looking at is we're looking at OEE, all right, overall equipment effectiveness. Now, this is availability times performance time quality, all right? So you understand that you have a planned production time, then you have a run time, and then how many cycles adds up to the availability, and then the performance within those cycles, and then the quality of the performance that was produced. And what we kind of need to do there is we're trying to work out where, when the device or part of the device isn't as good as it was. So you've got your good count there, yeah? And this is a great start because this tells you the machine, is the machine good? Does the machine need any maintenance right now? Maybe not, no. It seems to be marginal, or it seems to be great. But it doesn't tell you everything. All it's telling you really is the machine state, which is a really good start, don't get me wrong, but we need to kind of add more to it than that. And I guess where I'm going with this is I'm going to try and understand what we need to do around OEE to plus that, to actually get more value out. So people are smart data, and that seems like a very odd thing to say, but people have been monitoring and fixing and altering processes for since the dawn of the Industrial Revolution, and even not before that. All right, so there's always going to be someone in a factory that knows exactly what happens when something breaks. And so with things like legacy production lines, difficult and variability of the product itself that's being produced. So for example, tights is a really interesting one, how tights are produced, and ladies stockings. Large mold forces, so I've met people that actually sit there in car plants, and they can tell from the noise of the press if the press is not working as well as it was a couple of minutes ago. And they know it because they've been there. They sit next to this machine or work next to this machine all the time. And other things like the biscuit factory is a good example. And I'm going to use a biscuit factory as we go along, right? Oil spread of molds and ambient temperature. These people can see that, and they can go, yeah, that's not the way it should be right now. We need to stop this, and we need to fix some things. So people can be used to gather smart data, and it's really interesting to get them involved in a process, so they can actually see value in the knowledge they've put into it, and they can actually get more value out of it because they can just focus on more interesting things. Now, the scenario here that I'm going to use is Sarah's in charge of production line inspection here. She knows what products should look like, and she knows what the various different stages of production. She's been doing this job for at least 10 years. She knows which biscuits are within tolerances. She knows how the production line works that goes from raw dough mixture to finished product in a packet. And so she understands everything that goes into making a biscuit good and what goes wrong with it. So based upon her understanding, we can improve our OEE process, and she helps us with that. And then she can go on to do some more interesting bits and bobs around the factory as well, and not have to worry about is the production line going to go down in the next half an hour? Should I be looking at various different things? She can start looking at new technology and new biscuit types and things like that. So we're using Sitewise, and traditionally in a factory like that, what we would try and do is we would have the PLCs, for example, here looking after the oven state. So in a biscuit factory, generally your ovens will be numerous, and in a production line, the ovens will ramp up in temperature and then ramp back down again as the conveyor belt moves along. So the biscuits are cooking whilst they're moving. All right, but it only takes one of those ovens to start failing, and your batch is kind of ruined because you don't necessarily know when it started to go, and you've got slightly undercooked biscuits. Now, the inspection station here and the people manning the inspection station will pretty much know when that goes off the board, because they'll know either light biscuits or something else will have gone wrong. There'll be some sort of molding inaccuracy and other things. All right, so we're only taking, with OEE in this regard, part of the information out, because we're taking what the ovens are actually up to right now. So we're adding value, but we're not adding perhaps enough value. So let's move on and see what we can add, right? So what we've been talking about here in AWS is talking about, Andon code with Virtual Andon. Now, we're going to go into what Andon code is and the process around it. And then we're going to talk about process improvement using SageMaker ground truth with cameras, all right? Because what we really, really want to be doing is we want to be looking at the product itself in manufacture, and we want to be able to actually empowering our employees to actually say, well, hold on a minute, you're robotizing various different parts of the factory, but someone still needs to say, stop, this isn't working. Because cameras and robots and digital conveyor belts and things do not fix everything. There is still a good amount of knowledge there. So, Andon code. Why Andon code, and what does it do? So, Andon code is a manufacturing process that was pioneered by Toyota in the 80s on their car plants, and it gave the ability for any one of the workers on their production line, if they saw something wrong, to stop the line. And this is an important factor, and it saves money, because if a car plant carries on with broken cars because one of the production processes failed, and of course cars are incredibly complicated using a lot of subcontractors, you're going to end up making cars which are not fit for purpose, and they'll sit in a car lot and wait to get fixed for a very, very long time. If you can ask people to actually, say, hey, this isn't right, this needs fixing, we can kind of do better in the production line. Now, yeah, it's important in manufacturing, because staff can use their skill to save the business money. There's less production waste. You're allowing staff to validate situations, and it gives you more data points, because you can then see from what they're telling you, well, okay, that's very interesting. How do we automate that? Or why don't we automate bits of that? Creating a feedback loop is also keeping workers' input relevant. So you can actually say, okay, this is brilliant. You did a great job. What else can we see? What else can we look at? Where else in the production line is critical, that we need to stop things before it goes too far, because wastage is expensive because everything runs on a margin. With Virtual Andon, this is a service that we kind of, well, it's not a service, it's a set of products in AWS that we put together to try and get this to work. Now, there are two ways to put values into Sitewise. So if you look here, you see an alarm is triggered. What we've got here is a simple web page that allows the user to either trigger the web service via a physical switch, or they can actually tap on a screen and actually push a web page function. That you can run that web page very, very simply off S3, and our demo does that. And then you have Cognito authentication for that web page, and then you have an amplified backend and AppSync. So what we're then doing is we're then pulling out of that Amplify integration a topic, and we're actually saying, and we're publishing a set of rules. Now, what those rules do is they tell the Sitewise ingest API that, hey, somebody's pulled a cord, and it will add it to a marker in the data as it goes. The second point there is we've got a Lambda looking at the rules, and we could do a direct integration to SNS to say, hey, engineering, you need to know that somebody's pulled a cord for a good reason, and we've just validated that, so engineering can then be sent. You can also do it automatically via AppSync to a mobile phone as well. So this is allowing workers to actually respond to events that are happening in real time, and try and fix those in real time, which is incredibly important. So let's move on. So, because that's kind of cool, but let's move next. So the next thing is process improvement with machine learning. Now, you hear a lot about machine learning in the industry. It's doing this, it's doing that, it's driving cars, it's fixing patients with cancer, all those amazing things that machine learning does. But machine learning can also be used where there's a visual problem, and it can also be used when you don't necessarily know what you're looking at until someone tells you what to look at. They annotate the diagram to say, hey, there's a problem here. And you can use that in your service to actually make a model that is doing what the staff tell it that you need to look for. So, for example, if we use the example of the biscuit factory here, what you could say it to do is look for oval biscuits, look for biscuits that are too dark because they've been burnt a little bit, look for biscuits that have sunk because they haven't cooked properly. And so there's multiple things there, and we can actually move that machine learning model. We can train it in the cloud based upon the data that we've got, all the images, and then we can move that train model back to the edge to actually stop and start production based upon issues coming out. All right, because we don't want to spend a lot of money on cookie dough that needs to be thrown in the bin. So that service is SageMaker Ground Truth, and this is edge labeling, labeling of images as they get taken, because you can take them all the time, and then you can get your staff to kind of go, yeah, that's a broken one, that's bad, this is bad, because certain things in a production process, like with biscuits, like with making other products like soup, like like baked beans. There are issues around those processes that people can see, but they are visual. But you just need to look for them, and you need to be able to understand what they look like when they happen. So SageMaker Ground Truth here allows you to kind of either choose your own private workforce or choose a public workforce. It allows you to pay as you go, to actually to human label things that go on. All right, so you can take take raw triggered photos every other second, and you can do human annotations for that. Now, where human annotations apply is where you've got low confidence in understanding what's going on in the image. All right, and then what you can then do is you can use your training data, and then you can apply your machine learning model past the human annotations, where you've got high confidence and you know exactly what's going on. So there's biscuit problems here, there's biscuit problems there. You can kind of know those. So as it learns, as it grows, you need less and less human annotations, and you can do it more with automated ones, because there's only so many things that can go wrong in a biscuit factory, like in most other processes. And then you've got your training data, and then you put it out. So, and it also runs around a thing called consensus. Now, generally, consensus of images is important, because you really want to get multiple people to look at the same set of images to go, well, I think that's wrong. No, I think that's wrong. And here we are. Here we've got a dog and a what looks like a monkey. Okay, and then we've got Bob and Shirley think that the dog is the thing on the left, and they're obviously right. But Dan, who doesn't know what a dog looks like, seems odd, but okay, he's gone for the monkey. Now, SageMaker Ground Truth can actually take those validations and go with a consensus on it to say, actually, you know what, that's a dog. But okay, so we've got dogs and monkeys, brilliant. How do we apply that? How do we actually get that into something that's useful, like our biscuit factory? Now, we need to start by understanding what's a good and bad image. Now, if we look at this biscuit factory and we try to take a video, we try to take a video here, we've got all sorts of different problems. So you've got reflection, you've got different light sources. You might have an open window coming on here. Look at that. You've got a window. You've got movement in the background. That's the distraction. And machine learning is no different from a very small child that it gets distracted by things, doing different things, and claims all sorts of things to go on. So you need to really focus the images, and you also really need to focus what people are looking at. And so, and when I say focus, I don't mean down here we've got focus issues. That's another problem that you need to try and resolve. Okay, so if we look at another image, another way to do that image, we can see that, okay, so what we then need to do is we then need to have a specific field of view at the top there. So we've taken that green bounding box, and we said, this is my field of view that I need to evaluate all of the biscuits coming off the production line. Now, what I need to look at is I need to be able to annotate at first all of the biscuits that don't comply to my standard. So the bottom ones there, you can say, it's got a molding issue. Yeah, it's slightly oval. That's weird. What's going on there? So obviously one or multiple of the molds are not getting oiled properly. So that needs to be evaluated. What's happening there? You've got a pitted and crushed biscuit, which means generally that it didn't quite cook properly. Is it a minor problem, or is it the sign of something more serious? Can we match that to the data that's coming out of OEE and work out, is something happening on the left-hand side of the oven as it's coming out? And at the top here, we've got some slightly over-baked biscuits. So is the production line stopping occasionally at certain parts? Which again in itself is another problem, because you've got a mechanism failure or a mechanism that's about to fail because the belts keep stopping and starting. So these are the things that kind of you need to think about. What are we watching? Why are we watching it? How are we labeling that so you can get people to go, yes, definitely bad biscuit, very good biscuit, all of these So you need to know what a good biscuit looks like as well as a bad one. And so let's move that on to how we integrate that with the technical assets. So as you can see here, we've still got our ovens monitored, our ovens 1, 2, and 3. So we're taking all the data out of those and all the elements and the core temperatures and things. We're taking our readings out of the conveyor belt, because we now know that conveyor belts are important, because we need to know if they fail. So we're looking for bearing rumble. We're looking for pauses in conveyor belts, because that might mean the motor's not well, and other things. But what we're now looking at in our inspection line is we've got a camera. And we need an image trigger lander. So we're actually taking photos of the biscuits in their confined block. And we're trying to work out, based upon SageMaker ground truth, what's a good biscuit versus a bad biscuit. Yeah. And then we're incorporating that into our into our SageMaker ground truth. We're popping those images over the images that have been tagged by the web interface, and then we're then pushing them into SageMaker to actually train the model, as we've seen before. Then on the other side, with our Virtual Andon, we've got our web service that's also sitting in Greengrass on our industrial PC, and you've got a simple web interface there for the inspection station. You've got the ability to take a photo of the specific and label that on the screen. And then you've got the ability to press your Virtual Andon and stop the production line, because every biscuit is bad, and that's something that needs to stop right now. And then you can trigger the ovens to power down based upon your OPC UA connector, based upon doing all of that kind of good stuff. And so, as you can see here, it's a fairly complicated way of moving around, but it's super valuable, because once we've got all of that data, once we understand on an ongoing basis what you need to do to make a good biscuit on that production line, we can limit the amount of folks on that production line and get them doing more interesting things, and then we can make sure that the margins on that production line are protected. We're not getting mass failure that people haven't spotted, and we're not getting issues around the various different components, which we're also watching. And then in the cloud here, we've got the ability to look at the portal. We can actually see those conveyor belts and other things working. We can alert staff and engineering crews of various different problems that need to happen. And then we can do big searches in our glue catalog, our glue data catalog, and we can kind of work out for all of my production lines, all of my conveyor belts, which ones are performing the best and which ones are performing the worst. So I know in the evenings, when do I get my staff in to run maintenance schedules. Now, lastly, the back end of that, the bit on the ground, is Greengrass. Now, Greengrass, we just released Greengrass 2.0. Greengrass 2.0 is an interesting segue from Greengrass v1, which was written in Golang. It's all written in Java, and it's a Java virtual machine, and we've open sourced it. Now, what you get here is you get in Greengrass itself, you get a nucleus. Now, the nucleus is the service in Greengrass that pretty much controls things like the spooler, so working out when to send stuff to the cloud, the deployment mechanism, taking recipes and components and putting them onto the Greengrass system, the security model and certificate management. And then we've got the client, which talks MQTT to IT core. So you can actually send messages of how all of my components are doing to the cloud to say everything's working as it should. General telemetry about how the Java virtual machine's doing, how the OPC UA server's doing, that kind of good stuff. And then IPC. So it also handles all the inter-process communication. So if the Sitewise connector needs access to certificates, or it needs access to the stream manager and other things, Nucleus deals with that. Now, The Sitewise connector itself connects directly to an OPC UA server. So if you've got an OPC UA server in your environment, you can connect that up from the console. It's all console driven, or you can do it from the CLI. And you deploy this connector. You first of all deploy Greengrass into your factory floor on an industrial PC. And in other videos, we can show you how to do that. And then you run the connector over the top from the console. It installs. It talks to your OPC UA server or Modbus TCP server or an Ethernet IP server, and then pulls back that data. And then you're into asset modeling and then the assets themselves. And then the top there for our conveyor belt, we needed a camera component. So you can deploy lambdas on Greengrass, and lambdas allow you to take bits of C code, bits of Python code, bits of .NET and other things, and actually run them on the edge in your Greengrass node as components from the Lambda console. So, for example, here we're taking an ONVIF stream, and we're taking photographs from an ONVIF stream, and then we're forwarding those. We can either forward them as video segments to Kinesis via Stream Manager, or we can take individual photos from the video frame, and then we can either process them locally, or we can send them to an S3 bucket for processing later if it's not urgent. So multiple things you can do there. The last thing on the list here is the ability to run an HMI. So Greengrass has the ability via the nucleus, not just to run stuff within the Java virtual machine, but it also allows you to connect to devices external to the JVM. So, for example, that could be a screen, that could be a USB device. It could be any other thing like that. So this Node.js web server, also running as a Lambda, has the ability to broadcast a small thing to the screen to say, hey, press this button if you want Virtual Andon to work, press that button if you want to take a photograph. And it communicates all these things via IPC. So that's a kind of a basic overview of what Greengrass 2.0 brings and how it communicates with the cloud. So any questions on that would be great, and you know where to find me. So bringing it all together. Techniques we're working here is for, where there's heavily manual process, and we're trying to automate a whole bunch of manual objects so we can actually improve the process over time and improve the reliability of process, and make sure that margins are maintained, if not bettered. So we're looking for a better definition of data. We're looking for data from the products, so the devices that are making things, and that's OEE in general. But we're also looking for better data from the actual production line itself and the product that's being made. But then we need quicker validation of issues. We need to be able to actually allow a quick change in state. So if something's happened, if something's broken, somebody's pushed that Virtual Andon, we need to stop everything. But we also need to be able to show that this is the data up until the time it's stopped. And then we need, operator-based cognition. So people are smart, they're clever, they've been there for a long time, they understand processes. And then we need to implement, a machine learning backend to actually go, you know what, I'm going to take some of that heavy lifting off of you guys, so it's easier for you. You can just look at things and press a button and get on with your day job rather than having to do two different things at once. And then adding the potential of automation from this better understanding, moving the process on, moving it forwards. So I've put together a few things here around that. So we've got our Virtual Andon, we've got our Sitewise workshop, which is a great workshop which one of my colleagues has built. You also need to look at training data sets in SageMaker Ground Truth and having a look at how that works. And then we've got our Virtual Andon implementation as well. So, that's brilliant. Please have a look at those when you get some time. I've been Andrew Delamere. Thank you very much for your time. You have a good day now.